Recently, astronomers using the JWST uncovered thousands of these compact and extremely red galaxies, affectionately dubbed little red dots or LRDs. Now, these aren't just any galaxies. They're thought to be among the earliest formed in our universe, dating back to when the cosmos was just a toddler, around 600 to 800 million years after the Big Bang. Hey everyone, welcome back to our channel where we explore the wonders of the universe. Today, we're diving into an incredible discovery made by the James Webb Space Telescope, or JWST. We're talking about a mysterious population of galaxies known as the little red dots. So grab your favorite snack, get comfy, and let's embark on this cosmic journey together. You know, when the JWST was launched, it was like sending a super-powered eye into the cosmos. Its mission? To explore the universe in ways we never thought possible. And guess what? It's already delivering some jaw-dropping discoveries. So, what exactly are these little red dots? Well, they're characterized by their point-like appearance and striking red colors, which come from their light being stretched due to the expansion of the universe. This is known as redshift. Imagine looking at a distant car with its headlights on. The farther away it is, the more the light shifts to red. That's what's happening here. The JWST team analyzed a sample of 434 LRDs selected from the Cosmos Web Survey, which covers a vast area of space. They found that these galaxies likely host something called active galactic nuclei, or AGN for short. But what does that mean? An AGN is a supermassive black hole at the center of a galaxy that's actively pulling in material. As this material spirals in, it heats up and emits a tremendous amount of energy, making the galaxy shine brightly. So, these little red dots could be hiding some of the most powerful forces in the universe. Now, let's get a little nerdy for a moment. The researchers fitted these galaxies with spectral energy distribution, SED models, to determine their properties. This means they analyzed the light coming from these galaxies to figure out their composition, distance, and even their mass. Scenario 1. The LRDs are dominated by AGN, meaning their brightness comes mainly from the supermassive black holes at their centers. In this case, they found that these galaxies could have luminosities between 10 to the power 45 and 10 to the power 47 ergs per second. Basically, they're incredibly bright. Scenario 2. Alternatively, the LRDs could be compact star-forming galaxies, where the light primarily comes from the stars being born within them. If this is true, they estimated these galaxies could have stellar masses ranging from 10 to the power 8.5 to 10 to the power 10 solar masses. That's a lot of stars and a lot of mass. Now, why does this matter? The sheer abundance of these little red dots suggests that our understanding of galaxy formation might need a serious overhaul. Traditionally, we thought that supermassive black holes and their host galaxies evolved together over time. But these findings indicate that some of these black holes might have formed much earlier than we ever expected. Imagine a world where galaxies and black holes are like dance partners, moving in sync. But what if we find out that some of these black holes were already on the dance floor while their partners were still figuring out their steps? That's what these discoveries imply. But wait, there's more. The researchers also considered the role of dust in these galaxies. Dust can obscure our view of the universe, making it tricky to determine what's really happening inside these distant galaxies. Some of the LRDs exhibit signs of significant dust attenuation, which means that the light we see is affected by dust clouds in the galaxy itself. This dust can come from various sources, including the interstellar medium, which is the matter that exists in the space between stars. It's like trying to see through a foggy window. The dust can make it hard to see the bright lights of the AGN or the stars forming within. So, what's next for astronomers? With the JWST continuing to gather data, researchers are eager to conduct further observations of these little red dots. They want to explore their spectral characteristics in more detail and understand the physical processes that lead to their formation. If you're as fascinated by the universe as I am, make sure to follow the latest updates from the JWST team. Who knows what other secrets of the cosmos they'll uncover next? If you enjoyed this far in this cosmic journey, don't forget to hit that like button and subscribe for more exciting content. Share your thoughts in the comments below. What do you find most intriguing about these little red dots? Now, let's dive deeper into the science behind these little red dots. The analysis of the LRDs involved fitting their spectral energy distributions to both galaxy and AGN models. This dual approach is crucial because it helps astronomers understand whether these objects are primarily powered by star formation or by the accretion of material onto supermassive black holes. The researchers derived a bolometric luminosity function for these LRDs, which is approximately 100 times greater than that of UV-selected quasars. This means that these galaxies are not just rare anomalies. They represent a significant mode of early galaxy and supermassive black hole growth. If we consider the scenario where these LRDs are dominated by star formation, the stellar mass function derived indicates that they have stellar masses ranging from 10 to the power 8.5 to 10 to the power 10 solar masses. This is fascinating because it suggests that these galaxies are not only massive, but also packed with stars, potentially leading to rapid star formation episodes. The JWST's mid-infrared instrument, MIRI, played a pivotal role in accurately determining these stellar masses. Without MIRI, the mass estimates would have been inconsistent with the lambda CDM model, which is the leading cosmological model explaining the structure of the universe. As we unravel the mysteries of these little red dots, it's essential to consider the implications for our understanding of galaxy evolution. The existence of such massive and luminous galaxies at high redshifts challenges the traditional views of how galaxies form and evolve over time. The findings suggest that the early universe was a bustling place, with galaxies forming rapidly and supermassive black holes emerging sooner than expected. This could mean that the processes governing galaxy formation are more complex than we currently understand, possibly involving unique conditions that allowed for the rapid growth of these massive systems. Thanks for joining me today as we explored the incredible discoveries made by the JWST regarding the little red dots. If you found this journey through the cosmos as thrilling as I did, make sure to hit that like button, subscribe, and share your thoughts in the comments below. Until next time, keep wondering about the universe and all its wonders. See you in the next video.